Okay, picture this. A single molecule of carbon dioxide. Pollution. It's just been spewed from the giant smokestack of a container ship out in the middle of the ocean. Now, what if I told you that instead of just adding to climate change, that one molecule went on this wild adventure? An incredible journey, really, that ended with it becoming a totally useful product thousands of kilometers from where it started. It sounds like science fiction, right? Well, let's get into it.
So, this is where our story begins, in the world of international shipping. These massive vessels, they're literally the backbone of our global economy. They move something like 90% of everything we buy, sell, and use. But they have a pretty big, dirty secret. They are a huge source of greenhouse gas emissions. And because of that, the entire industry is under some serious pressure to clean up its act and do it fast.
So the race is on to find a solution. And that leads to a really fascinating question. What if? What if you could somehow grab the CO2 right as it's coming out of the ship's exhaust, before it ever hits the atmosphere? And then, what if you could actually transform it into something like this?
What you're looking at right here, this is the end of our molecule's long journey. It's now a fine, white powder, all neatly bagged up in a warehouse, ready to be used. It went from being pollution to being a product. But how in the world did that happen? And maybe the most important question of all, was the whole journey even worth it from a climate perspective?
To really get why this is such a big deal, we first have to wrap our heads around the sheer scale of the problem we're trying to solve.
To put it simply, the carbon footprint of the maritime industry is just enormous. So finding a way to slash those emissions isn't just, a nice idea, it's become a global necessity. And that is the massive challenge that this really groundbreaking experiment decided to take on. And that brings us to the hero of our story, a project that set out to prove a pretty radical new idea was actually possible in the real world. Okay, so this is the tech at the heart of the whole thing. It's an onboard carbon capture and storage system, or OCCS for short, and this one was fitted onto the container ship, the Evertop. You can think of it like a super sophisticated chemical filter for the ship's engine exhaust. It uses this special liquid, an amine solvent, to literally grab and hold onto the CO2 molecules before they can escape into the air. Now here's what's so crucial. This wasn't just some test in a lab. Project Captured was the world's first demonstration of the entire process. From start to finish, they put the system on a real working container ship, the Evertop. And while it was out on a voyage, they captured 25.4 metric tons of CO2 and then liquefied it for storage right there on the ship. But here's the thing. Actually capturing the carbon? Well, that was only the first step. Getting it to a place where it could actually be used, that turned out to be a whole other adventure. So first up, when they got to the port in Shanghai, they had to pull off this really delicate ship-to-ship transfer. Imagine trying to offload those 25.4 tons of liquefied CO2 from a monster ship like the Evertop onto a much, much smaller vessel. It's a super tricky operation, and it was just the beginning of the journey. Next, that smaller ship sailed to a place called Zhoushan, and this is where the journey made a big switch from sea to land. The CO2 had to be transferred again, but this time it was pumped from the ship into a tanker truck. I mean, every single one of these transfers is its own complex logistical puzzle you have to solve. And this map just shows you the final epic leg of the trip. That one truck then drove over 2,200 kilometers. It crossed several provinces in China, driving all the way to a factory in Baotou, Inner Mongolia. That is an immense distance, and it really highlights the massive logistical challenge of creating a brand new supply chain just for captured carbon. So after this incredible trip, what actually happens when the CO2 gets to its destination? Well, this is where the real magic, the real alchemy begins. So at the factory, the captured CO2 isn't just dumped or stored. It's actually put to work. Through a process called carbon mineralization, it's chemically combined with an industrial waste product, something called steel slag. This process actually locks the CO2 into a stable, solid mineral form. And in doing so, it creates two brand new, valuable materials. One is precipitated calcium carbonate, or PCC, which is used as a filler to make things like paper and paint brighter. The other is post-carbonated slag, or PCS, which can be used as a sustainable building material. So, look, it's an absolutely incredible technical achievement, no doubt about it. But it begs the most important question of all.
did this hugely complex, energy-guzzling journey actually help the climate in the end? To answer that question, you need something called a life cycle assessment, or an LCA. The easiest way to think about it is like a complete financial budget, but for carbon. It doesn't just look at the emissions you saved on the ship. Nope. It counts every single bit of energy used and pollution created along the entire chain, from the very beginning to the very end, from cradle to grave. So for Project Captured, the LCA broke the whole process down into 3 main stages. First, you've got the actual capture process on the ship, which of course takes energy. Second, you have that whole offloading and transportation chain we just followed, the ships, the trucks, all of it. And third, there's the utilization process itself, back at the factory. And here's where it gets really, really interesting. Look at the results. It turns out the biggest source of emissions in this entire chain wasn't capturing the CO2. It wasn't even using it at the factory. It was that epic 2,200-kilometer journey. The transportation part of this pilot project created the most emissions by far. And that is an absolutely crucial finding if you want to make this technology viable on a large scale. So the pilot project worked, but it also uncovered a major hurdle. And that brings us to the future and how we can make this whole process a lot smarter. You see, the study didn't just stop at the pilot's results. It then ran a bunch of what-if scenarios. What if the factory that uses the CO2 was built right next to the port? What if the transport was done by a more efficient ship or even a pipeline instead of a truck? This is how you figure out the best path forward and really understand the true potential of the technology. Ultimately, when you capture carbon, it all boils down to 2 main ideas for what to do with it next. On one side, you have utilization, or CCU. That's what we saw in this project. You turn the CO2 into new, valuable products. On the other side, you have storage, or CCS. And that's where you just pump the CO2 deep underground into geological formations, trying to lock it away forever. And that really leaves us with the big final question. Project Captured proved that this whole carbon utilization idea is technically possible, but it also shined a huge spotlight on the massive logistical challenges. So as this tech develops, the crucial decision we're all going to face is this. What is the wisest use of captured carbon? Should we use it to build a whole new circular economy? Or should we just bury our emissions deep in the ground and hope they stay there forever?